we are going to evaluate the 6 trig functions together for this particular angle. Now, when we evaluate the 6 trig functions, we need to know what all sides of a triangle are. So I know what the legs are. They create the 90-degree angle. I need to know what the hypotenuse is. So I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. It doesn't matter which leg I refer to as A and which leg I refer to as B. 8 squared plus 4 square roots of 11 squared equals c squared. 8 squared means 8 times 8. I know 8 times 8 is 64. I'm going to write this down twice. And this happened to be the reason why many of you made a mistake in correctly identifying the hypotenuse yesterday. So how do I go about multiplying these? So I'm going to multiply numbers that are in the correct form. So these are in the same form. So 4 times 4 is 16. And then the square root of 11 times the square root of 11, I multiply the inside. So 11 times 11 is 121. Now, I know that the square root of 121, and this is where the mistake was made yesterday, the square root of 121 is 11. I don't put a square root over the top of it. I've already applied that. On your calculators, can you please type in at the same time I am? I've asked you to have a calculator out. The same way, 64 plus 16 times 11, and I end up with 240. Now, in order to isolate the c, which represents the length of this hypotenuse, I'm going to take the square root of 240. And now I need to reduce it. This is something that's very important. If you have not memorized the perfect squares, please write this down. 1, 4, 9. How do I randomly come up with these? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6s, 7s, 8s, 9s, 10s. I'm going to do a few more. 11, 12, 13, 14, and 15. Okay, are you ready? Why am I writing down those perfect squares? Because we have to see, can I break this down? To correctly break it down, you're always going to start with the largest number and work backwards. So I'm going to go 240. Please do this with me. I'm going to divide by 225. If I don't get a nice whole number, it doesn't work. So 240 divided by 196. That doesn't work. 240, 169, 240. And sometimes when I rush, it's easy to make a mistake. So if you see me type in a number wrong, just please let me know. I know 240 divided by 100 doesn't work. Divided by 81, 240 divided by 64. Oh, I'm getting closer. Divided by 49, 240 divided by 25, 240 divided by 16. Oh, there we go. Does everybody see that? 240 divided by 16. Now, here's a mistake you could have made. If you started from the bottom, notice how 240 divided by 4 also works. You're like, well, why couldn't I have used 4 instead of 16? When you don't choose the largest perfect square that divides into the given number, you're not going to be able to fully reduce things. So I'm going to rewrite this as, so the square root of 240 is equivalent to 16 times 15. How did I get that? 16 times 15 is 240. What is the square root of 16? 4. Okay, so I've done the hard work. I'm going to come up here and write 4 square roots of 15. This is equivalent to the square root of 240. I'm going to grab another piece of paper so we have a little better visual here, and I'm going to come off to the side. Okay, remember when we identify the sine, the cosine, and the tangent, we are simply comparing two of the 3 sides of a triangle. We're making a ratio, and all we're doing is we're following directions. So let me call on students to see if they remember, and if you don't, just say pass. It's okay. Dina, do you remember when we say sine, what 2 sides am I going to compare in what order? So you're going to say like something divided by something.
Opposite over hypotenuse.
Opposite over hypotenuse. Now the next problem, that's great. The next problem is the students are often like, well, I don't know what sides here. So this is our angle. If I was going to take and go directly across from this, this would be opposite. So I'm going to write OPP. The diagonal is always the longest side, known as the hypotenuse of a right triangle, and only have one side remaining. This is the adjacent side. So I'm going to come back to exactly what Dina said if you couldn't hear in the video. She said it's a ratio, and the order matters, of opposite over hypotenuse. So the opposite from this angle is 8, and the hypotenuse is 4 square roots of 15. We'll come back and put it in proper form later on. The cosine. Cosine. Josh, do you remember what cosine is? Good. Adjacent. So 4 square roots of 11 over 4 square roots of 15. This is great. Tangent is probably even a little more confusing. Foster, do you remember what tangent is? Awesome. Opposite, okay, over adjacent. Now, before I even get into, these are the primary trig functions. We'll do the secondary trig functions over here. The cosecant is going to be the reciprocal of sine. The secant is reciprocal of cosine. Cotangent is reciprocal of tangent. But before I do anything, I want to do some quick reducing, because we have to put them in reduced form. 8 over 4. Well, I know that 4 goes into 8 twice. 4 goes into itself once. So before I even write this in proper form, I have 2 over 1 square root of 15. Here, 4 goes into itself 1, 4 goes into itself 1. Or in your mind, you probably think cancels out. Really, they reduce to 1. So I haven't put anything in proper form, but this is what I have so far. Again, 4 goes into 8 twice, 4 goes into itself once. Can you give me an honest, now I'm not going to ask people that were not here yesterday, but if you were here yesterday up to this point, if speed's not a factor, a 1 through 5, if you're following what I'm doing right now, hands up 1 through 5. It's okay to be a 1. It's okay to be a 1. Okay, you ready? Here's our next thing. This is mathematically correct. It represents a value that describes opposite length divided by hypotenuse, but it's not in proper form. Proper form would leave no square roots in the denominator. So as we talked about yesterday, there's a shortcut. We take this value and we throw it up top. So I throw it up top and then I rewrite it on the bottom with no square root. So if I find it over here, it's going to be 2 square roots of 15 over, well, 1 times 15 is 15. Circle. Okay, next up, let's do cosine. I'm going to throw this up top. So square root of 11 times the square root of 15, and then I rewrite it on the bottom with no square root. Okay, grab your calculator, please. We need to take 11 times 15. 11 times 15 is 156. And then we have to go back and ask ourselves, can we reduce the 156? So let's find 156. Okay, 156 would be right in between here. So I said 156. I meant to say 165. 165 divided by 144. What am I doing? I'm just making sure I can't reduce it any further. So I'm taking each one of these and I'm dividing by the perfect squares. And if you happen to see one that works, just shout out to me. I don't think it's actually going to happen. And by the way, as a reminder, dividing by 1 does not actually reduce anything. So we can see none of them ended up in reducing. So here we go. I have 11 times 15 is 165 over 15. Same thing here. I'm going to throw this 11 up top. 2 square roots of 11 over 1 times 11. So 2 square roots of 11 over 11. There is the sine, the cosine, and the tangent. Okay, honest right now? A thumbs up, I understand you, Miss Bradley. A thumbs down, I'm not understanding, or you're going a little bit too fast. A thumbs up or a thumbs down right now where you are. Okay, no thumb up or no thumb down is you're not paying attention. Gotcha. All right, cosecant. I'm going to go back to before I put this in proper form because these are equivalent. It's just not proper form. And watch, I'm going to flip it. 1 square roots of 15 over 2. And you're like, why did you flip it? Because the relationship between these two is they're reciprocal. They're just flipped. So I'm going to go back. Oh, let's see, what can I do here? Even when I'm here, if I flip it, I still have to work on this because this isn't wrong, but it's not in proper form. So proper form is going to take the square root of 11 and I'm going to throw it up top. And then I'm going to rewrite 11 on the bottom. Now, I already know if I take 11 times 15, I get 156. So square root of 165. I keep switching those digits. So 165 over 11. Okay, I'm going to go back to before it was in proper form, and then I'm going to take the reciprocal. So 1 square root of 11 over 2. This is the sine, the cosine, and the tangent. This is the cosecant, the secant, and the cotangent. How do we figure out the hypotenuse? That's what I'm going to do right now in this video. So I'm going to say A is 5 squared plus 2 squared is 13 squared equals C squared. 5 times 5 is 25. 2 groups of 2. 2 times 2 is 4. Square root of 13 times square root is 169. This is equivalent to 13. 13 times 4 is 52, and 52 plus 25, yeah, 52 plus 25 is 77, and when you take the square root of 77, it cannot be broken down. All right. right, so I know sine is opposite over hypotenuse. By the way, I'm going to go ahead and do the cosecant next. Square root of 77 over 5. I'll put it in proper form later. I know cosine is adjacent over hypotenuse. And then I'm going to come back over here and do the secant next. Okay, then I'm going to do the tangent, which is opposite over adjacent. Now, when I look at these, this is in correct form. This is in correct form. Everyone else, I got to do some work here. So correct form means to move this up to the top and rewrite it on the bottom without any. Okay, I'm going to move this up to the top, so 5 square roots of 13 over 2 times 13, because this would be 2 times 13, which is 26. These are going to be a little more work, so I'm going to grab my calculator. And so it'd be, I'm going to move that 77 up to the top, and then rewrite it over 77. Well, what is 13 times 77? Ooh, a really large number. And then I got to see, can I break that down, which really stinks. I may start with the back and then have to break it down multiple times. Let's just see if I can do any of this. Or maybe that number even is a prime number. I don't know. I don't think it is. I think it's a prime number. Okay, so it's 101. So I'm going to write this as 2 times the square root of 1001 all over 77. Over here, the 13 joins us up top, so it would be 77 times 13 all over 2 times 13, which would be 26. I know that top number is 101 over 26.